Hello everyone. So what am I going to talk to you about today? I'm going to talk about the journey of Cinch's journey to AWS. So we'll talk about a bit about what Cinch is, and we'll go through an outline of what that journey looked like. So we'll talk about where we started from. We were initially as a team, we weren't using AWS. So talk about how we made that transition, where we went through, how we launched a new service during the pandemic. What did we learn from that process, and talk a bit about what it cost us, and also about where we're going next. So I will say that this conversation starts in sort of 2019 and runs up to the current day. I only joined Cinch in October 2020, which was I think the week before the launch of the new service we've just launched. So I'm doing a bit of storytelling here, but hopefully it'll prove informative. So Cinch.co.uk launched as a sort of a consumer-facing brand as part of what's called the Constellation Automotive Group. Traditionally, you might be most familiar with that, is there are some other companies in the groups, including We Buy Any Car and also British Car Auctions. But although we're kind of related to those, we don't really have too much to do with them in terms of the delivery. We're very much an independent kind of service. So initially, it was started as sort of a experimental consumer brand. We're looking to try and do new things in the market with a small team based in Manchester and sort of most of the business operations based down in Surrey. What you would find is from a technology stack perspective, it was kind of more what you consider traditional, which is around mainly using C#, MVC style applications, happen to be in containers these did, and also React and TypeScript on the front end. So what are we trying to achieve as our mission? So it's pretty simple, really. It's just trying to take all the pain and hold-ups and all the issues you have in terms of when changing a car, buying a car, or looking after your car. Basically trying to remove the faff from car ownership. And what did that look like as our initial draft? Well, really it was more of a traditional kind of car aggregator where we'd produce adverts on behalf of car dealerships in terms of make it so you guys could find your car. We were really, we launched this in July 2019. A team was being built around this project and it started to turn into a mini business. So where we were at the start of 2020 was we had 2 engineering squads and a small business team looking at seeing what we can do to really try and reinvent this experience for consumers so they can make it easy to find a car, easy to get the right car, am I paying the right amount of money for the car, answer all these kind of questions in the best way we could. March 2020 arrived, so as you probably all know, this is when the pandemic started to really hit the UK in force. So at the time, we were in the process of moving to a new office. This is actually the floor plan of our office. We never fully moved in. It took us a few months really for sort of the dust to settle and for us to understand where we were. The whole company moved to being remote, and it worked really well. But we were very conscious that it's a really challenging time for the motor trade in the UK, and we really need to understand what we can do better to make the experience less faffy for our consumers. So we looked at doing a pivot, and there was a decision to move to a direct consumer sales model where we would sell and deliver to people at home cars. So we needed to do that, and we need to do it very, very fast. So the question was, how do we do that? So this chap, Simon Wardley, quite an interesting guy, sort of invented something called Wardley mapping. This is a Wardley map. But he actually launched the world's first, I think, public platform as a service back in, I think, 2005. So it was called Zimkey, I think. And what's really interesting is in terms of, to say, as an organization, as a business nowadays, we really want to be focusing on where we can drive the most innovation, where we have the biggest bang for our buck when we spend time looking at engineering and building digital services. If we zoom in a little bit deeper, we can see, this is just a reflection of the truth. The truth is that, with the commoditization of compute, you don't want to be spending a huge amount of time building, Kubernetes clusters, data centers, all these kind of things. You want to focus on where your differentiators are as a business, which is, we want to sell cars and remove the fat from car purchasing and ownership, not build IT systems. So it's really interesting, and for us, the focus needs to be on that customer experience and how it moves forwards rather than as a technology play. So, how do we want to end up doing that? We made the decision, we're going to build a new platform. We really want to sort of commit to moving up the value chain. So, we're going to deliver the best customer experience we can, whilst also, doing it all via serverless computing and SaaS technologies where possible. We don't want to buy things. We don't want to build things if we don't have to. Of course, we want to buy things if we can, if it makes it easier and supports our key business. So, to point that, we made the decision to simplify our technology stack. So just use one language everywhere, which really helps us get bang for buck. It gives the most transferable skills between engineering teams and makes that work a bit better. And so the key thing for us was we got to do it within 4 months. So, we'd got to this position. We weren't users of AWS at the moment, but we'd done all this in a kind of a cloud agnostic way, regardless of which platform we chose to run our serverless systems. And in the end, the decision we got to is that we chose AWS. Why did we choose that? Well, we're based in the UK, in Manchester, in the northwest of the UK, and based on our understanding of the available skills, resources, and the supporting ecosystem around AWS, it seemed like the best option for us. We are now a heavy user of SaaS products. Our support stack isn't based on AWS. Our analytics stack isn't based on AWS. Neither is our sort of engagement tooling or our data warehouse. But all of those services do integrate with the AWS ecosystem, and that provides a huge amount of value for us. So, we take that approach of having a bounded buy around services. We buy the best service we can within the world to do a specific service, a specific thing, rather than building our own. So we sort of made the decisions. We've done those things. We got to the starting blocks, and we had a hard deadline. We had a few months to build this thing. We think about how we're going to do it. So our primary concern at the moment was about how do we get engineers going faster. How do we get C# engineers to move to TypeScript and build serverless applications when they used to be running MVC applications? Very hard. We need to do that whilst also getting guardrails up so the teams can start moving at pace. And you have to remember that the thing we're building is very different from a traditional e-commerce platform in terms of, we're selling unique, bespoke products with a very high price, sometimes up to sort of about £80,000, I think is the most expensive vehicle on the platform at the moment, and do it very, very quickly. So how do we do that? So what we kind of decided to do is at the inception of the project, while we got our AWS guardrail sorted out, and while we were thinking about what that product needs to be, we put our engineers in a room basically and said, work out what you want to do. So some of the key things we decided to do is, we talk about a tool chain which we adopted at the moment, but very much we're looking at sort of delivering a lean walking skeleton into production as soon as possible, so that those teams can iterate quite quickly rather than having a big bang release when we go live with everything at the end. So we spent a lot of this time building proof of concepts, getting to the point where everything worked. So toolchain wise, we use GitHub Actions mainly for our continuous delivery, and just found it was the best fit for our engineers. We use TypeScript everywhere, which we've talked about in a little bit area. There were some decisions around code style. We looked at both more OOP structured TypeScript and also functional TypeScript. The functional arguments won out in the end, mainly because a lot of our engineers use React on the front end, and we continue to use React, which kind of uses that functional style. So it helped again around consistency, which made less work for the developers. We ended up selecting serverless framework for our main tooling and what we're doing for deploying applications. We did look at CDK at the time, but the developer experience wasn't really there with CDK. This was back 9 months ago. I think it's changed since. I'll talk a bit about that later. But yeah, first serverless just worked for us. We did make the decision to store all of our data in DynamoDB. This is just a constraint. We didn't want to run any relational data stores. We didn't really want to run any databases, so it made a good fit for us. And then, although I think we do still have some data in S3, but not a lot. And then, the last decision we made was that all inter-service communication needs to be done using EventBridge. So that's how we want teams to talk to each other. That's what we're going to use as our communication fabric for messaging. So it worked quite well. So we'll talk a bit now about what that's the technology stack, who's using it, and how does it get delivered. So this is kind of what an example team might look like within Cinch. What you'll see is there's no testers, which is quite interesting. So we're very heavily reliant on a lot of test automation rather than manual QA. But it also means that engineers themselves are accountable for the quality of the product they produce. So they're also accountable for production. So we follow some of the DevOps methodologies. All the engineers in the team are responsible for the production environment. We expect everyone to be sort of a T-shaped person, so that although you might have an expertise in front-end, back-end, or DevOps, you're able to do work across the team. It's quite challenging in some ways, but we found it works for most of our engineers. One thing you'll note within this, we're not called DevOps engineers, we call them automation engineers, because we don't want them to focus on dev and ops, we want them to focus on automating pain. So it's kind of a very explicit call out from us. Obviously squads, we pull in other people in terms of roles as we need to. But it's like what our squads do is they do follow kind of, I'm not going to go too far into organizational design, but they do follow methodologies that are kind of expressed in the team topologies book around, they have team APIs, we talk about ways of working, communication patterns, these kind of things. But this is, again, the only type of team we have in the company where they're focused on customer outcomes. So we are missing we don't have an infrastructure team or a platform team at the moment. But what we did is, in terms of going forwards, was we decided, we've got to have shared guardrails. We've got to get a landing zone in place in AWS. We've got to set up what we're doing. So what we ended up doing was adopting kind of a virtual platform squad. I know that sounds a bit convoluted, but what we found is when the project initially got going, sort of the automation engineers we had would focus very much on the guardrails, while everyone else kind of noodled around solving the problems around what does the application look like. And as we went forwards, the virtual platform work sort of really tailed off as everyone focused on the delivery. So we did that, and then sort of we put these guardrails together. We were doing it all on, we used kind of more or less all the recommended out-the-box tooling, so control tower, organizations, everything kind of worked. It was great. We kind of dialed the knob up quite hard because our sort of wider group of companies is quite a traditional, very kind of compliance-oriented organization. So we wanted to make sure we had all the bases covered, and it worked really well. I will say there'll be some interesting outcomes to this model when we talk about our billing, and also about, we can say now that some of these guardrails are starting to creak a little bit, but was generally the right thing for us to do at the time. Very simple approach to organizational units. We separated data warehouse, security, and core. So core's log archive, audit, that kind of thing. Security was very much around just a security account, and then we have our data warehouse separately. Prod, non-prod OUs, very straightforward. We do use SCPs quite extensively for stuff. But you can see, and then again with accounts, we've just got production account, non-production account. There's a few of these in terms of how it goes forwards, but again, very simple. So, in terms of where we were in terms of all the services, we were literally using everything. So we had a number of conformance packs, we're using single sign-on for identity, all the kind of recommended turnkey stuff that was out of the box. And although it just worked really, really well for us. So principles, talk about, sort of application principles and what we learned and what we thought was the right thing to do. We put some constraints on the teams as they went forwards to try and enforce some architectural behavior. First one of those is made sure that, services, when they serve synchronous requests via APIs, it only comes from a local data source. So they're not allowed to make HTTP calls to external services to fetch that. It's from a local source only, in this case, DynamoDB. Made sure that all squads communicate with each other via EventBridge. We didn't want any direct HTTP calls between teams, so they should be dependent for their own data, and they should be able to publish those events. So very much an event-driven approach to how we do things. So I will say in this diagram, it does include the fact that we're taking a DynamoDB stream, we're emitting events from a Lambda behind that stream. That's the idealized way we want teams to do it. Not all teams did that initially, and that's kind of, we'll get to that in terms of some of the challenges and problems we had later on. We did say then in terms of service discovery via DNS, so very straightforward for clients, coming via React. Each teams would sort of own a vertical slice of everything from the front end of the website all the way through to the back end services and what's there. So it kind of made quite good. And the last one was, we made sure we had continuous delivery in place from day one. So, it would be your first commit would, stand up the application. It would be up as a walking skeleton in production. So we found that quite useful and iterated, and that was great. And then we got to our launch day, which was very interesting. And what did our launch process look like? It went really, really well. Interestingly enough, I joined the team about a week before we actually had our launch, and we sort of pushed the final version of the applications and the services live 2 to 3 days before we actually started to launch then a national TV campaign, which had been booked months in advance. So it's quite an interesting situation. But where did we end up then? So you can see here Rylan, our lovely brand ambassador. The launch went amazingly well. We were really, really pleased with how it went. It was we started delivering that fat-free buying experience to customers very, very quickly. But I will say, we had a lot of challenges. There's a lot of stuff that had to sort of be dealt with under the hood. Nothing that impacted on customers, but it was a really tough few weeks for our teams dealing with edge cases and other problems we hadn't originally anticipated. Staff throughout the business actually worked really, really hard in terms of, from when we launched through to Christmas. It was exciting. But one thing that did really help us was the fact that as part of that work where we deployed our applications over the previous few months running up to the launch date, was that we'd actually been using continuous delivery, deploying to production every single time, so we had a walking skeleton. And as we added more features and more components to make that final service, we did it gradually over time. So go live was basically change a DNS entry, which really helped us de-risk it and make it work better for us. So, what did we learn? Lots, as I kind of alluded to. So one thing, we'll break down these and just go through them. So something that really worked for us is, launching a website and then a couple of days later starting a national primetime TV advertising campaign was interesting, but, serverless just works. And, I can confirm that. We did national TV advertising in sort of primetime TV, going from sort of, 10, 15 requests a second to 100 plus requests a second in less than a minute. We actually saw latency go down of the service because Lambda is anti-fragile. The less cold starts you have, the better the service gets. It just kind of worked. DynamoDB just worked as well. We didn't really have to worry about anything, which was lovely, having to not worry about scaling servers, read replicas, anything. It just worked. We did make some slightly interesting decisions around DynamoDB, but I'll come to that again in a bit. One thing we really found we needed to focus on was that, you have to limit what a Lambda function does. So this is quite an opinionated view, but it was around that when we had our Lambda functions, when we saw a Lambda function doing lots of things, in terms of when we see a system that works a bit like this, where a Lambda will write something to a database and then it'll send an event to Event Bridge, that ended up causing us a lot of pain in the long term, where we had things didn't quite work, then they did work, and then unreliability. So, what I can recommend is break your Lambda functions down as much as possible. A single Lambda function should really have a single side effect, which means it writes one item to the database, it might emit an event, it might do something else, but limit so there's only one side effect per Lambda, and you kind of treat those Lambdas as elements of a production line. If you're trying to write a change, you want to work through a number of different Lambdas or a number of different Amazon services, and keep them as simple as possible. And that's generally something that reoccurs again and again, is that when you're working in a serverless environment, keeping your individual functions as simple as possible is a really good thing to do. What I will say is this model maybe doesn't work depending on your execution model. So if you're routing all traffic through a single Lambda function and you're doing like a kind of proxy MVC thing, then yeah, maybe you want to do it differently. But we found this really helped. It did cause us some challenges. We had a lot of pain sort of just after launch with limits on CloudFormation stacks, but thankfully the resource limit got lifted from 200 resources to 500 resources, and we just don't have that problem anymore, so that was amazing. Other things, Nosql was really challenging for some teams, so there was some sort of confusion around DynamoDB. We had some standard patterns that we were using, but we did have a bit of sort of cargo culting implementation in some of the engineering teams. Thankfully we're past that now, but we didn't do enough to close the knowledge gap, and I'd really reiterate that we do need to do more. So we had quite a lot of for the first probably month in production after launch, we had some services doing scans when they shouldn't be. We had some challenges around that. Performance didn't really impact significantly, but you could definitely see there was pain coming if we didn't do something about it. So we did that. It took us a couple of months after launch to really iron these out and address these problems in the services, but we're now in a much better place. I'd recommend for anyone who's thinking about moving to serverless and using DynamoDB, have a look at Alex DeBrie's DynamoDBguide.com and buy his book. It's literally essential reading. People talk about watching Rick Houlihan's YouTube videos, but really just read the book and buy it. I know it's expensive, but it's worth it. So other things for us, this was a real pain. So using event-driven systems, we're using some systems where some of our transactional systems, we're using an event sourcing approach, which means that we receive events in the system, we'd write all of those events to a DynamoDB database, and then we'd use a separate sort of read model, Lambda, that would read all of those events and build an aggregate view of what was going on. That worked great and actually really saved our bacon in a couple of places, but there was a few times where it went wrong. Quite often this was to do with when we were integrating with third-party services, where we'd have webhooks, where a lot of our requests weren't idempotent, so we'd get updates. We might get updates more than once for the same data, or we might, quite a common scenario was we found a bug in the internal system. In order to fix the bug in other downstream services, we'd have to replay events into Event Bridge. When we did that, we started to see some side effects from some Lambdas which weren't idempotent, and although we tried to make everything as idempotent as possible, this did cause us some real pain. So I think we've now got a lot of automation in tests to make sure that if you send the same event twice to Lambda functions, the same result occurs. And this was really important. Again, it's about making things simpler where possible. Strive to make each different unit of code as simple as possible. So coming onto that theme is we found that coming from a lot of engineers working with C# MVC to sort of more TypeScript Lambdas resulted in some interesting code. The code worked, which we're good to say, but we did have sort of implementations. Although we were using a lot of a functional approach, we did have implementations that were we had layers of code, layers of indirection, layers of just confusion really, and it got very, very confusing very fast. So a lot of teams have kind of undertaken some major refactoring over the last couple of months. We've even had one team completely rewrite their services, and they're bringing up a new version, which is much simpler, much easier to understand, much more reliable. So, we kind of acknowledge that we probably didn't do enough to kind of put in place really, really clear guidelines about what good looks like for the engineering teams, and we're trying to do that. We're trying to create some reference projects now that make it easy to understand, but it was really challenging. But as again, lots of learnings there about making things simpler, which is really hard. And then talk about observability. So the team's kind of we didn't really have enough of a focus on observability moving forward. As we rose to launch, everyone was very focused on getting the product shipped, getting the service operating. We did build some dashboards, but we found that probably in the month and a half, maybe 2 months post-launch, we focused hugely on improving observability, improving dashboarding, giving us much better visibility of what's going on, making a lot of use of, we use Datadog for some of our services, we AWS for others. We're using real user monitoring on the actual website and tying what's going on in the user's browser with what's happening on the back end using X-ray and tracing. Yeah, we found it really well. We ended up having to roll some of our own middleware and various other things to come across those stuff. I know that I've come from a world of Python serverless and using Lambda power tools is very good, and hopefully there's a TypeScript version coming soon, but we're now in a much better place. But it was something we probably didn't put enough effort into as part of launch, and we had to play a lot of catch up. So that's kind of some of the learnings we took from our launch and what happened post. We spent a couple of months really post-launch, really just tidying things up and getting them in place. But now do a bit of a breakdown about what it cost. This is quite interesting, really. So this is a kind of a percentage breakdown of our bill in November, so 1 month after launch. You can see I've broken it down by category. I'm not going to talk numbers, obviously. There's some commercially sensitive information in here. It's not a massive bill, but it's quite a large bill. We've wiped out tax and support and those kind of things. But you can see in terms of the first line of the bill, the biggest cost for us was management and governance. So our biggest cost of everything was CloudTrail, then config, then CloudWatch. Now, CloudTrail and config is quite interesting. So because we have a very heavy push towards automation, we don't do any manual testing at all. We actually create and destroy a huge number of CloudFormation stacks. So for instance, one of the projects I know will stand up, I think 10 CloudFormation stacks on every commit and then tear them down again as part of its integration tests. So we're doing that kind of really heavy usage of automation, which means that we churn CloudFormation an awful lot, which means we get a huge number of events being emitted into CloudTrail. So yeah, although we can see this is I think 57% of our bill was basically CloudTrail, config, CloudWatch, and a few other bits and bobs. It's actually fine because compared to our wage bill or anything else, these are still very small costs, which is quite interesting. Next bill for us was networking content delivery. Kind of makes sense. Primarily CloudFront, so it's all about our CDN, which we use extensively. A little bit in NAT gateways, but not a lot. Again, most of our Lambda functions don't run in a VPC, so we're just relying on IAM for security. But what I still will say then, next cost was security identity compliance, which is quite interesting. So again, because we turned the guardrails up full on most systems, we had Security Hub, Guard Duty, we had a bit of MACI, WAF, all these kind of things, again, representing about 10% of the costs. And we're not a compute yet, now we're databases, so about 2.8% was DataMyDB, which was quite interesting. So I think we were still doing quite a lot of scans in this period of time, so it's probably higher than it should have been. And then finally we get to compute. I think we worked out it's about just under 2.5%. We're not running any instances or containers. I think we are starting to experiment with Fargate for some use cases at the moment, but everything is Lambda, a very, very small percentage of our costs. And then finally we get to storage, was about 2.5%. And developer tools, 1%, which was X-ray. It's quite interesting. So our X-ray cost was half of our Lambda cost, which was quite interesting. And then eventually we get to some analytics costs, very small again. This Kinesis Firehose primarily because we're shipping data to our analytics stack. And then last of all, I think we have, which is quite interesting in terms of representing about 0.3% of our bill was application integration. So SSNS, SQS, EventBridge, Tiny. I think when we worked out this, we worked out that kind of the direct costs, about only 10% of our bill was actually directly related to running the application. Everything else was either CDN or management and governance. So it's quite interesting in terms of breakdown of costs. So that takes us to kind of what are we doing next and where we're going in AWS. That was from November, that bill. We're now in February. I think we're doing a lot at the moment in terms of moving forwards to where we go into the start of the next financial year. We're kind of very much going from startup to scale up. I think we started the organization with one product engineering area with 2 squads, then it went to 5 squads. We've now split in division again. We've got 3 different areas of product engineering, each with 4 squads each. They're each kind of aligned with different outcomes. We're doing a whole bunch of new product launches soon, so it's really interesting time. There's a lot of challenges, but from a technology perspective, some of the stuff we are looking at is the stuff we alluded to around Control Tower. That got us working, got us out the door, but those guardrails are starting to creep now, so we're looking at maybe changing what we're doing with an implementation there and sort of being a bit more intelligent about what we're doing. to do that, we're maybe standing up a dedicated team. They won't be a platform team in the sense of what you'd normally think of a platform team, which is about accelerating engineering delivery. It's mainly on a kind of a compliance, monitoring, guardrail perspective, so more like a kind of central infrastructure team rather than a platform team. I come back to CDK again. Really interesting. I had discussions with engineers this week around CDK. Everyone was starting to give it a thumbs up, much more so and much more engineering friendly than serverless framework now, which is really interesting. So stay tuned on that one. We've got Lambda tools for TypeScript, which is coming, and Power tools for TypeScript coming through. And as with us, we're a growing business. We've got a lot of things going on. There's a lot of constraints emerging, bottlenecks, lots of interesting problems to solve. We're doing everything from selling direct to end consumer to managing delivery of those vehicles across the country. So it's quite a lot of technical domains and challenges that are quite interesting. We've got some interesting new R&D stuff going on as well. But what I will say is, that's kind of where we are. Expect to hear more from us probably over the next 6 months. You'll see us on the telly again. I think we've got a number of interesting sports sponsorships going on this year, so lots of stuff happening. And I will just throw in at the end that we are hiring. Drop us an email or reach out to me on any of the usual social networks. And that's a quick summary of where we've gone with our journey to AWS. So I think that's all, thanks. And I'll hopefully be around for some questions.